I'm opening the book just in case, because a few of you guys said that you might have some questions. Anybody still grading? A couple more seconds. Pause. What is on the screen right now that we hadn't gone over yet? Ooh, good call. Pause on grading homework. Turn in your notes real quick. Oh, how can I still expect how much you can do today when we didn't go over area? It was just plugged and shoved to the formula that was chilling in a nice big important box in the section, right? Let's see how much initiative we have. But it is an important formula, and I do want you to get it in your notes that way. When you're studying for the test, you don't forget that it's even a thing. Not as many formulas as last chapter, for sure, but still some important ones. Law of sines being 1, this area formula being 2, and this one is given side, angle, side. This one's being given side, angle, side. That's what plugs in super nicely to the formula. So if you're given side, angle, side, all I have to do for area, as you guys are writing the formula, is just take 1/2 of the side times the side times sine of the included angle. And it's as easy as that. Plug and chug and you're done. Given side, angle, side, an area formula is as easy as 1/2 side times the included angle. Now here's a good question, as some people are still writing it. Anybody know why? Pourquoi, pourquoi, how come it works? If you didn't have this formula, how would you have to do area? What's the normal area of a triangle? 1/2 base times height. So if we do have a non-right triangle, I need the height, and the height is always perpendicular to the base, right? Wouldn't the height or the altitude be right here? So what's the struggle? I have a base. I don't have a height. So what if I was to make this height unknown? What do I know in that little triangle? I don't know the height, but what do I know? I know the hypotenuse, and I know what would the angle be? 180 minus 102, which would be 78. How could I use 78 and 52 to find my height? Hopefully all those scholars are still alive. What would it be? Sine! Nice, 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 because sine takes opposite, yeah? Over. Hypotenuse, thank you. It's getting kind of painful. So then h is equal to 52 sine of 78. And that's my height, true? And what's the area of the triangle? What's my base? What's my height? You should be able to make up the formula, not just use it. We could do that every time. So, you could make up the formula every time and then use it, or you could memorize the formula, which is pretty nice and simple and sweet. But it doesn't come out of nowhere. It comes from finding the height, showing the height, It's perpendicular to the base, using a little bit of trig to solve for that, and then plug it into 1/2 base times height. All right, cool kids, we got this in our notes. It's not a crazy formula to use. Might take a little bit of work to memorize, but it's pretty easy once you get the hang of it. And if worse comes to worse, there's always a way to do it on your own, as long as you remember 1/2 base times height. And height always goes perpendicular to the base. Sometimes it's outside the triangle, though. If it's an obtuse triangle? Yeah, if you have an obtuse angle. All right, back to homework. So then number 44, you were just plugging into the area formula. Solve, 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 final answer 4.5. And number 30, why was it impossible? What were they comparing it to? Who's H? Did you have to compare it to H? How did you guys figure out it was impossible? Yeah, plugged it into law of sines, and what happened when you tried to take sine inverse? Error! You didn't have to do it their way. But their way is they went ahead and took the information, and they said, okay, if I have an angle A being 58, which is there-ish, that didn't work well. Microsoft Word is done. It doesn't work. My smart tools. And if I hit undo, nothing happens. It's really lame. If I do this, nope, that didn't work. If I do this, now it works. Okay. If I have 58 degrees and 4.5, come over here where no, did it again. Touchy. Okay. 58 degrees. Angle B is 12.8. Side A is 4.5. How did they know it's not going to be able to hit? Compare it to? What's the shortest I could possibly have? The right triangle. So you can go ahead and say, hey, well, if x is the shortest, we got to figure out whether 4.5 is smaller, bigger, or the same as. So we can go ahead and do sine of 58 equals x over 12.8, move the 12.8. They call that xh, the height, and they find that height and like, hey, the height is 10.86. Yeah, 4.5 is not going to connect. The shortest distance is 10.86. Okay. So they just did it a different way, but as you guys quickly noticed, law of sines is enough to tell you, yeah, no, not possible, not going to work. Number 52 was a word problem. There was a lot going on. Do you guys have some bearing? Or did they just show you a cool picture? Did you have to make the picture on your own? Are we alive? They're not exactly rhetorical questions. Maybe the last one was. Okay, let me freeze the screen. Let me pull up the problem. I see a lot of writing, which makes me think that we have a question on this one, and we're just not quite willing to ask it. Anybody have a question? They're willing to ask it? No? Ah, thank you. Okay. Let's go figure out what's going on. I had to give you at least one tricky one, right? Chapter 6, Section 1. Number 52. While I'm pulling up homework from last night, let's pop down really quickly to number 62 because we don't like 52, so we're probably going to have to talk about him a little bit longer. 62 was a little bit funny, but you were able to find a distance between the 2 points. This one's just a little shorter to explain, so I'm going here first, then we'll go to the book. You could have found the distance between these 2 points. The shortest distance, if you were to do a straight connect, would be 5. Did they tell you that angle A was acute? I think so. I think that was a given. So it wasn't an obtuse one. Wasn't an obtuse one. So if you knew, I shouldn't be drawing it there, it's going to move it and then you brush it again. Okay. You know the shortest distance between 2 is 5. And I think you knew making up the question as I go, but I think I remember this one. They're basically trying to have you fill in different possibilities for when you're going to have 2 possible triangles or 1 possible triangle or no possible triangles, right? Okay, so 5 is actually this. It's the hypotenuse. My apologies. 5 is the hypotenuse, because you could find that by finding the distance between 2 sides. If you were to connect in a right triangle, the H would be 3, but that's not necessarily the triangle that we're trying to make. But the H, if you were to connect perpendicular, the H would be 3. So right now, if this side was a 3, you'd have 1 possibility. So we know that 3 makes 1 possibility. That's a right triangle. However, we also know that any side, if this third side wasn't 3, if it was bigger than 5, if it was a 6 or a 7 or an 8, if it's bigger than 5, the only way to swing is out. So then greater than or equal to 5 can't swing in, it can only swing out. That's another time where you're only going to have 1 possible triangle. However, if you have a side being between 3 and 5, what's going to happen? Like say we had 4. You could come in and connect and make a triangle, or you could swing out and connect. So anything between 3 and 5 is going to make 2 triangles. And then what's going on, without even reading your homework, guys, if A is less than 3, how many possible triangles? Oh, he's going to dangle. He's not going to connect. So that's going to be my 9. Tricky thing on this one is realizing what you have to take your 2 points, figure out that this side is a 5, figure out this is a little baby acute angle, and then find the 3, which I just counted by 1, 2, 3 because of my point. And then you reference everything between the 3 and the 5. So bigger than 5, only 1. In between 3 and 5, 2. 3, well that's only 1. But anything less than 3, 9. It's going to dangle. Okay, let's go back to 52. Were there any odds that you guys didn't like? Oh, sorry, 56. Leaning Tower of Pisa. Let's start with 52. Any odds we didn't like, though? 52 and 56. Yeah. 35. Okay. Let's zoom in and see what's going on. Let's start with 35, just because he comes first. Then we'll go to our word problems at 52 and 56. 35, what did you guys do? We know the 36 is a little guy, right? We know his opposite side is 5. Which we could say, we're trying to find angle side B. That's no fun. So the triangle has 1 solution, 2 solutions, and no solution. Okay, I'm going to write now, make the 5 an opposite of a right triangle. It's kind of how we start by judging. And if he's opposite of the right triangle, let's go find the hypotenuse for a right triangle of what that B would be. So we would use sine again, right? So we could say, okay, B is equal to 5 divided by sine of 36. Can you guys give me a quick value for that, Ryan?
Well, I thought B wasn't the hypotenuse since A squared plus B squared equals B squared. So that would be...
It doesn't have to be a hypotenuse, but in the example that I just showed where we were trying to figure out whether the side can have 2 possible or just 1 possible or it dangles, compared to what we did yesterday, I'm starting with a right triangle. I'm just starting with the right triangle. So if it is a right triangle, 5 has to be, side A has to be across from angle A. So if it is a right triangle, this would be the opposite, and that would have to be the hypotenuse. Now, as soon as this side is no longer 90 degrees, you're right, it's not a hypotenuse anymore. What did you guys get? We needed 5 over sine of 36. 8.5-ish. Rounded to 8.6-ish, just to have an approximate. Okay. So if B is 8.6, I know there's 1 solution, right? Because the only way to put that together would be with this little 5 being 90 degrees. Okay, now we're a struggle. Now we're at a dilemma. What if this 5 didn't connect at 90 degrees? What would have to change for this 5, first of all, to dangle? Wouldn't B need to be longer? If B was longer, if B was higher, what's going to happen to this 5? It's going to be removed, and is it going to connect?
No.
Okay. So we know right away for the no solution, for number, it was 35, right? Okay. If B is greater than 8.6, if it's longer than 8.6, this 5 is going to become removed and it's going to dangle. Okay. What if B is less than 8.6? The 5 couldn't go straight down, but what could it go? It could swing out. Now, hold on. How short could B be such that 5 would swing out and swing in? Remember the relationship? It could be 7, it could be 6, it could be 5. It has to be greater than 5. As soon as B becomes 5, these two match. 5 can't swing in, or else it would just hit the B side. So if B is 5 or 4 or 3 or 2 or 1, the 5 can only swing out. It won't be able to swing in because B is too small. So then the two solutions would be B between 8.6 and 5, but it can't equal 5. As soon as B equals 5, this 5 side couldn't swing back. Which leaves us with one solution if B is less than or equals 5. Sorry, that's more equals, it doesn't look like it. Does that make sense? Great question. That's definitely a super tricky one. Did I only give you 1 in that section? Okay. Quick heads up, you could have looked at, oh, it is odd. Never mind. I did not give you an even in that section. That was on purpose, but that means Calc Chat didn't really help. Los Santo, I like the visual way. Pause, guys. Is there a big old table that might have helped you a little bit on that one? Maybe. Maybe. You guys don't want to memorize the table. Remember we talked about it the other day? But could you have used it? Yeah. I suppose. Because you could have made the H the 5, and then you could have thought about what this B is, but it doesn't exactly, it kind of shows me. It might have worked. It might have worked. But no one wants to memorize it, so if we can get the visualization down, it might help. Going back to homework. Okay, word problems 52, 56. Let's go find them. Oh, well that's helpful. It's just not going to show that page. It's not going to show any pages. It's going to freeze. Okay. Sometimes gotta love technology. All right. E for effort, F in success. All right, cool kids. Help me out. 52. I'm going to pull up the answer key just so we can use it as a reference or as a guide. Here's our 52. They gave you the whole picture. Oh wait, this is section 6.2. Never mind, it's not a baseball problem. I know. Oh, but they did give you the picture. You didn't even have to worry about the bearings because they gave you the picture with everything all labeled, even though they say bearings in there. Okay. What was the goal? Find the distance of the fire to the tower, which they labeled as B. Is that pine knob to fire? Did you find both? Okay, we want us to find A and B. Okay. There's a lot of triangles going on, yeah? But what do we know? We know the side length of 30. So we know from the lookout tower to this other tower, I don't know, from the two towers, the distance between them is 30, and we know all kinds of angles. Should we be able to solve this?
Yeah.
Yeah. So long story short, you could have looked at the 80 and the 65 and said, hey, subtract it, this little guy is 15. You know 30. This looks an awful lot like a law of science problem in the sense that, oh, this is that 90 degrees? No, we don't know that, do we? Yeah, but where did 65 and 70 come from? I don't think they show you the 70. They don't show you the 65. Okay. So that's not there. That's easy to find from just angle subtraction. Okay. So we can go ahead and do sine of what? 15 degrees all over A. Is that 90 degrees? I'm messing up.
Something like
It doesn't show 90 at all, does it?
Is it 65 next to 70? That's not so heavy.
it's a bunch of
No, I know, but if we have the
What's the
65
line
there,
drawn,
you
though?
know
Is
that
that
something
north?
on the other side of it
yeah, we
is
just
the same
look
in
at
that
time
time.
65
It's
is
geometry.
And I think it is geometry. I'm just trying to figure out where they told you what the line was. Is it just from north south? Oh, it is. Okay. They told us south 70 degrees east. So this is north, this is south, this is north, this is south. Which means, what is the relationship between these two lines? Parallel. Since they are parallel, we're able to use geometry. And that's where the 65 comes in. It is the key. We can use geometry. This can be a transversal, right? And what do we know about alternate interior angles? They're congruent. So you had to figure out that when they drew these lines, they were talking about the bearings going from north towards the east or from the south towards the east. Then you were able to say those two are then parallel, that's a transversal, these are congruent, ha, that's 65, so ha, that's 70 plus 65, which is 135. So therefore, what must this angle be? Well, 180 minus 15, right? 180 minus 15 minus 135, which would be 140, 150, is that 30?
Yeah.
So then C is going to be angle 30, and that makes all the difference in the world, because then can't we set up love signs with, I don't like the way they do it, but it technically works. Sine of 30 degrees, all over 30, and I can solve for whoever I want. So it made all the difference. The struggle was seeing those two as parallel lines, and then being able to make that alternate interior angles are congruent, jump. But once we have it, solve for A, solve for B, solve for whoever you want. Is that good? Okay, so 56, that's the Leaning Tower of Pisa one. Anybody have a question on that, or just want to see the answers? If you have a question, raise your hand real fast. Oh, okay. So Leaning Tower of Pisa. Letter A, final answer for the angle of lean is 5.36, or you could have 3 decimal places, is what I prefer. But it should round to 5.36 if you're checking. Letter B, you would end up with sine inverse of, you don't know what d or theta are, but you would have just gotten the beta by himself by taking sine inverse of both sides. You would have plugged in the unknowns and solved. You're just rearranging a formula. Sine inverse of d sine theta over 58.36. Letter C says, hey, let me give you something to plug in. And so it gives us that we can plug in that beta is 84.64 minus theta by going ahead and adding the angles that we know, subtracting from 180. It's unknown, but it is in terms of theta, so we can plug in for beta, who he is. Now we only have 2 unknowns. Then they say solve for d again, so move everything to the other side. Plug into your calculator with your table set up, being starting at 10 and going by 10s, and plug in the different possible betas as a result. So you started off with 3 unknowns. We can't deal with that. They give us a relationship, or have us use a relationship to get 2 unknowns, solve for 1 variable, and we can go to our calculator and plug into a table to find different possibilities. So that's what's going on. All right, last call on 56. Any questions, raise a hand. First year ever, no one asked about Leaning Tower of Pisa. All right. Cool kids, here we go, section 6.2. Law of cosines. Law of cosines. You gotta take initiative. If you have a question, you gotta let me know. Yeah. Okay. And you're finished with section 5.2. Who would have known we were close to the end? I would have always said that would have been the wisest thing. It's up to you. You can start 6.2 and then awkwardly start a new book in 6.2, or you can listen today and then have to watch the video later, or you can write on a separate piece of paper and copy it into the composition. So those are the three choices I see, so you choose what's best. You choose what's best. Law of cosines. You guys are getting new formulas down, yeah? No. Hopefully now it's a yes. And the funny thing is, I heard yesterday that you guys start seeing a lot of cosines in geometry. This is the 3rd year.
You started geometry.
Strangely enough.
I don't see geometry.
Yes. 2 pages probably.
My geometry teacher kicked me out of the class with the coffee.
With examples, maybe 2 pages.
Kicked out for association.
You can always work backwards if you're going to turn around in.
I love how you
I know our new curriculum involves it, but Thomas, you're right. You guys were actually on the old curriculum still, because you guys were in Algebra 2 last year, Geometry the year before. We just adopted new books last year, so I'm not actually sure. But maybe your book has stuff that your new book doesn't.
But the new books that
Oh,
the old
well,
book
sure,
had
Because
all
the
the
new one is supposed to be an improvement on the old, so therefore.
So then we didn't need all the old stuff from the old book, is what she's saying.
You don't need all the old stuff.
Yeah, but if we learn something that's not in this new book, then that
Geometry
means...
is pretty standard as far as what you learn, with congruence and similarity and triangles and circles and if-then statements, Pythagorean theorem.
Is that when we first started like
Yeah.
Yeah, but before we had
Logic
It's
is
like
one of the
proving
most useful
triangles.
we had to like
skills.
write out stuff though. It wasn't like just like doing that T-proof thing. It was like actually like writing out like all the
Like the
steps.
rationale.
Yeah, really cool. I'm like, what is
I should bring you guys an actual proof.
this?
The geometry ones are still like unbounded.
See,
There
For
are proofs
years
that are
of-
whole studies like whole doctoral theses.
you think you're smart when you're doing it, and then it's just like you find out you just get this snippet. Just do a
But
little
sometimes a snippet is all you really need at that point.
It's too much. I need this.
Have you guys at one point been like, God would just show me why this is happening right now? But then if you realize if he truly showed you all the why, I don't think you could handle it.
That's true.
I don't think you'd appreciate it. I don't think you'd understand it. Sometimes you would. Most times, be too overwhelming.
I want to look for this formula.
What?
We could look for this formula.
It's a lot of collaboration.
That's what I said. That's
Like,
why I asked
how
Mr.
do you
Chan, like,
think
who
of
thought of
this?
this?
I just showed you guys the area one. It wasn't that crazy, right?
Okay, but like stuff like this, like okay, well, like cosine and stuff. Like, somebody
That's
has
why
to
I
figure out
asked
how
Mr.
that
Chan,
works.
like, who thought of this?
Doesn't it look like
B squared equals C squared.
doesn't it look a lot like Pythagorean theorem?
No, I know.
Yeah, but
like,
how did somebody figure it out for right
Yeah.
triangles that if I
like, how did they
add
come to the
these,
conclusion
if I
of
square
A
both
squared
of
plus B
these,
squared equals C
this will
squared?
equal this one?
Actually, that one's geometry. That one's
It's
geometry.
just like-
Mr. Shane teaches you show why.
Yeah.
That's
We have
As Mr. Chan, he just told me to accept.
we have Mr. Chay's first year teaching for math and science.
over 10.
No, he was our physical science.
Physical science.
Oh,
Yeah, it was back to back. I would go straight from math science to science.
Don't even leave. You just take outside. Take a step outside. Get away from
Yeah, I got kicked out for everything.
Kicks you out.
I got kicked out for saying things right there. Okay, but I kind of deserve to be kicked out something because I said next to next. So,
I remember like Sam's. Yeah. Actually, no. Sam's really good.
I get it now.
HPrecalc does also.
You still do that?
really cool.
No, it's not doing that.
Like,
So they just.
said next to him just now.
Yeah.
They don't have really good theirs.
Still.
I mean, even like last year, you didn't get a watch it. He did
My first year in math, I got it past
Hard.
what's his name?
They said the best class was like.
Hey guys, what's on the board right now?
That's good.
Torture.
Yeah.
Exactly.
Right.
Oh, wait. No, it's
An airplane?
It's a right triangle with A and B and C, true?
yeah.
What is A squared? Isn't that A times A? So isn't it literally the area of the square?
Okay.
A squared is area of a square. What's B squared? Area of a square with sides of B. What's C squared? Area of a square with C. Guess what's true about that area plus that area? If I was to take these little squares and if I was to cut them up, and guess what? They would fit perfectly in. Why? Because A squared plus B squared is C squared.
But how do they think about like
Yeah, how do
squares?
they think about the squares?
If I take this square and make it into this square.
Just saying, it's a geometric proof. That's
Like,
why.
it makes sense.
It's just
but at the
because
same
they're way
time, it's
smarter
like,
than anybody in this
how do you think
generation.
of this?
Right. Law of cosines. The formula itself that theoretically you were supposed to introduce to a long time ago. And shown why it works. Is really helpful for side, 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 or side, angle, side. Why? Look at the formula itself. The little letters are, lowercase letters are sides, right?
Yes.
So literally, this tells me, hey, give me B, give me C, give me its in between angle A, and I'll give you little a. Give me 2 sides and an angle, I'll give you a side. Or, give me 3 sides, and I'll give you that angle. However, if they give me 3 sides, would it be fun to plug in 3 sides to this and then have my unknown way over here? No. Which is why it's like, you know what, if that was the case, you would need to subtract the a squared to solve, subtract the b squared to solve, divide the whole negative 2ab to solve. Hey, you could just memorize that there is another variation, another way of writing the formula. With the a squared and b squared move over and the negative 2b divided. So to be honest, this entire column is just rearrangements of the original law of cosines formulas. But rearrangements that could save some time and save you from making some mistakes. If you were given SSS, this column will be nice. If you're given SAS, those variations will be nice. But technically, these are the standard law of cosine formulas. And if you ever didn't know an angle, you could always just write this out and then solve for cosine of A. So it's up to you. Do you want to memorize 3 more? Or do you want to be fully confident you'll never make a mistake as you move all these guys over and solve for him? We'll see. We'll see. We'll see if today can help. But long story short, there are the 3 standard forms and there are the 3 alternate rearrangements, alternative forms. Let's see how each of them are useful. What are you given? A non-right triangle. All sides, in this case, of a non-right triangle. Now, some of you are going to be like, oh, I like the rearrangements, but then you have to memorize more. So let's see where the rearrangements come from. The rearrangement comes from seeing side, side, side and saying, why not law of sines? Why not law of sines? Can you figure that one out? As you're drawing it, as you're writing it, side, side, side. What would happen if we tried to plug into the law of sines?
There's no angle.
There are no angles, and the problem is we need 2 in the formula, so we need at least 1 to solve, right? We can only have 1 unknown in law of sines, so that's not going to work. Because we have sine of big A over 8, sine of big B over 19. We could do sine of big C over sine of big C over 14, but the problem is we have 2 unknowns. We can't solve for that. I don't know. So we're not going to. We're going to say, there's another way to relate it without law of sines. Now guys, as soon as you see trig in any formula, long story short, somehow they took a triangle with no right angles and they made right angles. And they figured out relationships between opposites and hypotenuses and adjacents, and that's where these formulas come from, law of sines and law of cosines. That's where they came from. But for right now, I think I gave you a good homework problem to think about the where they came from. But for right now, just see if we can use the formula you've been introduced to in previous years. And the formula says, thank goodness. I say find angle A, which means, look at the formulas. There's only 1 angle in each of the formulas. And the 1 angle that's there tells us what side does that equal to. So I'm looking at the standard forms. I know there are the rearrangements. Just hold on to that. You don't want to have to memorize 3 more. If I have angle A, I want little a on the outside. Quick way of remembering is that the angle and the side on the opposite side of the equals, they need to match. They need to bookend the formula. So I have little a on one side, cosine big A on the other side. Little b, cosine b. Little c, cosine c. Corresponding angles, or angles in their opposite sides, sides in their opposite angles need to bookend the entire formula. So if I want angle A, I can say, okay, I'm going to use the little a squared equals the b squared plus the c squared minus the 2bc times the cosine, law of cosines, A. Some of you guys have already figured that out and have already even started plugging in. Because you know that little a is 8 squared. Little b is 19 squared. Little c is 14 squared. Now hold on, just in case you don't want to memorize those rearrangements. You would plug into this formula. How would you get a alone? Don't think of getting a alone. He's inside, trapped in who?
Cosine.
Think of getting cosine a alone. Algebraically, what's the first thing that you would do? Subtract the 19 squared. And also subtract the 14 squared. Yeah.
I would just use the alternative form to do that.
Yes. So remember, you can use the rearrangement, you can use the alternate form, but then you have to memorize it for a quiz test. So it's up to you. So I'm showing you where the alternate form comes from, because it literally is just a rearrangement. Because if you were to solve for A, who's in cosine A, I would subtract 19 squared first, right? And I would subtract 14 squared next. So the 19 squared got subtracted, the 14 squared got subtracted, now I have negative 2 times 19 times 14. P.S. I'm also trying to put this in my calculator only once. In case you're wondering. Why divide?
Because it's being multiplied.
It's being multiplied. So then you would need to divide by the negative 2 times the 19 times the 14. Divide by the negative 2 times the 19 times the 14. Okay. Those of you guys that plugged into the rearrangement, yours should look very, very similar. Go look at the rearrangement real quick. Cosine of A equals. Now what's weird? Something's different. Yeah, the signs are different. Because in the rearrangement, it says, instead of saying a squared minus b squared minus c squared all over negative 2bc equaling cosine A, what does the rearrangement do? It says, yeah, it says ew, a negative, that's gross. Let's multiply top and bottom by a negative 1 so that all the signs look prettier. That's what the rearrangement does.
The c squared be plus.
So then a negative times a negative. A would be a negative, B would be a positive, C would be a positive. Nope. It's positive, positive, and then it's. When I distribute, the A became negative, because he was positive, so negative, positive, positive. So technically, mine should work out the exact same way as your rearrangement should work out. So could you memorize 3 more formulas? Sure. I mean, it's really just one kind of if you memorize it. But could you also just memorize the standard and then move it all? Yes, just be careful that you're moving legally. Subtract, subtract, divide by the negative. Wait a minute, we want to solve for A. What do we do to both sides? Cosine inverse. So even the rearrangements, you have to do cosine inverse of both sides. So A is equal to, can you guys plug all that into your calculator in one fell swoop to avoid mistakes? Cosine inverse, I would use the alpha y equals. People with old calculators, remember, put big old parentheses around the numerator and denominator. We can go degrees, that sounds good. Victoria.
22.6 was around
0.6?
I got that 0.75.
0.75. I have a couple with 22.075, one with 22.
I got.
There's just a little bit off. That's all we're supposed to find. How could we find angle B if they wanted us to find all the angles? We could do the exact same thing. Or now that we have an angle, could we actually go back to law of sines and say, oh sweet, we have an angle now. So we can do angle, side, angle? Sorry, side, angle, side.
Because it's not
I think it's easier. I use something.
it's not the exact one.
But we did use the decimal, and now if you plug in this rounded, yeah, it'd be pretty rough. If you plug in all the decimal places, it's probably accurate enough to match once rounded. But Andrew's right, it's even technically if you plug this in with all the decimals, it's still been rounded somewhere, so it still does introduce a little bit of error. But probably not enough to see any difference as to how we would round it. Could you do law of cosines again? The answer is definitely yes. Sorry, pause. Any questions about plugging in? Could the alternate form have been a way to start?
Yeah.
Yeah. Put on a test, then what do you have to do? Memorize it. Or start here and then move and solve for cosine. Okay. Shoop, shoop.
Oh, I think you meant something.
What about this guy?
What's that?
There's only one option for where to start. There's only one option for who to solve for first. Who's the guy that we have to solve for first, or else it's impossible?
Side B.
Who? Side? Why side B?
Because if we're going to find side A or C, we need to have a good side.
I wouldn't say that. But I don't think you mean side. Do you mean side AC? Because we already know those two. Why do we have to solve for side B first? The angle is given. We don't have enough for law of sines, but why though? We have an angle. Can't we just do sine of B over? We don't have enough to have an entire ratio for law of sines, so we can't solve. We have an unknown side B with an unknown angle A or an unknown angle C. We don't have enough for law of sines. We have to use law of cosines. We already have an angle, so we better find it. Remember, if we have an angle, what has to be on the other side of the equation? His side. His side has to be on the other side of the equation. So we have the 6.2 squared plus 9.5 squared minus 2 times 6.2 times 9.5. Put it carefully into your calculator, but if you do it right, you plug it all in one fell swoop, square root both sides, and there we go. Plus or minus square root? Do we have to worry about that? Why no? Yeah, in context, we're just looking for lengths of triangles, not in Cartesian planes and distances, directions. We're just looking for distance, just looking for length. So positive square root is the only domain that we're looking at, only positive numbers. So, positive square root, both sides. You do it all at once. You guys remember how to find this little guy? Second apps, or we could be super snazzy and make it 20 over 60. What do you got? 9.3? 9.3. Thanks, David. Would you be done? We still need angle A and C, but you could do it. Alright, we'll get started homework tonight. We'll go over ambiguous case and how it shows up in law of cosines tomorrow.